Hello friends, welcome to my channel. Today we will talk about few important collection types such as vector, HashMap and HashSet, and we will touch upon box type, which is a smart pointer. Now let's create our own first vector type. Vector collection is one of the most useful collection type, using which we can store a huge amount of similar data type content. The size of the vector is unknown at compile time. It is heap allocated, and data can grow and shrink at the runtime. This is vector macro syntax. Vector macro is a syntax sugar for creating and initialize data in one line. To modify the data, we have to make alphabets as mutable so that we can add and remove the content to the vector. In this two line, we have added D and E to the alphabets vector by using push method. And we can see the debug output in the right hand side in console. And now we'll explore small utilities available in the vector class or vector module. To access the third element C, we can use square bracket notation with index. So the actually data which is C in this case will be written and printed in the right hand side. Now let's see the two methods, length and capacity. Length and capacity are both different concepts. Length is simple to understand. In this case, we have 5 elements A, B, C, D, E. So length will return 5. Capacity is the number of elements in the vector can hold without reallocating. It can be equal or greater than the vector length at any time. IsEmpty is a small utility function which will return boolean true or false, which checks vector is empty or not. This first and last, as the name suggests, it will return first A element and last E respectively, and both of them will return an option, sum with payload. And if there is no data available, so both of the method will return none. One very important point is to remember here is that the payload itself is pointing to the reference, not the data itself. So the data is borrowed, not the ownership is being transferred. So once you do this length, the length will remain unchanged. It is 5. It is not a mutable operation. This is a read only to get the accessing those first and last element from the vector. On the other hand, pop removes the last element from a vector. It will return also the sum E, but the length of this vector is modified and it reduced to 5 to 4. If you see the return type of pop, it is option with the payload directly, the value directly. So unlike first and last, it is not pointing to the reference. It is pointing to the self data or the data which vector contain. So the ownership is being transferred. In this case, we are debugging, but if you want to assign some variable, so the ownership is being transferred to that particular variable. As we already seen, like to access this third element, like C, we can use a square bracket notation and pass the index. If you're trying to access a non-existent index, using the square bracket, then it will panic or your program will be crash, so no further code will be executed. So it is bit dangerous to use the square bracket notation. So there is another approach where you can access this element by index. So using get, we can access any element from a vector. Important thing to note here is that it returns an option type with the reference. In case of outbound exception or the key or the index doesn't exist, so it will return a none. If you see in this example, so the program won't be crashed. Now let's see how we can use for in loops to iterate through the vector, which is most of the time you are going to do in any program. So this is a simple iteration using for in loop. So this iter method or iter function returns an iterator. Iterator is a special kind of trait which is used in almost all the collection type available inside Rust. So I've created in previous video that how you can implement your own iterator implementation to get its own functionality. So using for in loop, you can loop through all the elements of alphabets, and alphabet points to reference to each element. It is not the actually data, it is the reference to the individual elements. So wherever the reference is returning and wherever the ownership is returning, you have to pay special attention to it. So if you can see, like A, B, C, D is getting printed in the right hand side console. If you need to access index, you can loop through using a enumerate on top of iterator. Enumerate is also a special type of iterator which yields a pairs or tuple of index and alphabet, where index is the current index of iteration and alphabet is the value returned by the iterator. And if you see here also, the alphabet pointing to the immutable reference to the actual data. It is not the data itself. And in the right hand side, if you can see 0A and 1B and so on is getting printed. In case you want to modify the data, you can access the mutable iterator also. Now let's see how it looks like. So you can get hold of mutable iterator using iter underscore mute. So in this case, alphabet will be to mutable reference, ampersand mute character. So using this star, you can able to change it. To access the actual data, you have to use star, which is a dereference operator. The original data it is pointing to. So star alphabet, the original data will be getting replaced by X. If you try to print it, so all the elements will be X now. XX. So as per your different logic, you can call some different function to update the correct data. Now we'll talk about HashMap. In this line, we have created an empty mutable HashMap. Unlike vector, HashMap is not part of the standard library prelude. That's why it is complaining that it is unable to resolve. So use of undeclared type. So we need to explicitly import from standard library. But still it is complaining. At this moment it is complaining about the type annotation. It is not able to auto-infer which type your HashMap is pointing to. So either we can add type info explicitly here. For example, what would be your key and value type? Or As soon as we add our first element into the HashMap, type will be auto-enfold. Now let's do that. So both the errors will gone. So HashMap is nothing but a key value pair. So it contains some key and it contains some value. So we have added some, string type of keys, and we have added some integer values. Using get, we can access the value from the HashMap. As an argument, we need to pass key as a reference, and the return type is option type, which is holding a reference to the actual data, not the data itself. So if the key doesn't exist, it will return none. Like in case of a vector, we can use for in loop to iterate through the different keys and values. Using this for in loop, we can access the reference to the key and value pair for each iteration. Because here we are referring this HashMap as a reference with ampersand. Either we can get rid of this reference and we can get this actual data. So the ownership is being transferred instead of borrowing. So after this for loop, we cannot access this scores anymore. But if you use ampersand, that only the borrowing or the difference will be iterated. So after that also we can use it if you wish so. On the right hand side you can see this key and value is printed. So using this remove, we can remove the key from the HashMap collection. So this yellow is being removed. Now this HashMap will only contain blue and green. Now let's discuss a different concept. So we can use custom struct, we're going to create in a minute, as a key to the HashMap. So not only the primitive types or the standard library type like string, integer we can use as a key, but we can use like custom type as well. So in this case, we have created a point struct, but we must need to implement equal, partial equal and hash trait. Because of this trait only, so we can provide point as a key. Otherwise this point cannot be acted as a key if you don't have this equal, partial equal and hash trait implemented. Using this derive macro, the functionality is auto implemented. We don't need to write code to implement it, the hash implementation or equal or so on. If you choose to, then also it will work, but you have to provide your own custom implementation. Similar to earlier, we can create like point instance in the left hand side as a key, and we can pass any value. So this point maps now refer to the point as a key and integer and as a value. So using the earlier like for in loop, we can loop through these point maps and the key value will be printed. Because we have used like struct as a debug macro, so this is using colon and question mark, this is get printed. So this point as a key and value as a 10. Now we'll talk about HashSet. Under the hood, a HashSet is implemented as HashMap. And like HashMap, this is also not part of This is also not part of the preload. So we have to import it, and as soon as we are inserting a particular value, so the error will be gone. So under the hood, a HashSet is implemented as a HashMap, where the value is a void type. So it has only key type. So it stores always a unique value. If you insert duplicate entries, it replaces the last value and no error will be reported. So we can add 3 unique values to the HashSet. And this looks like a, with curly bracket and 4 distinct values. This contains is a small utility function which will return boolean value, true or false, to signify if the value is present or not. In this case, London is present, so it returns true. We have created another similar HashSet, favorite cities. We insert 2 values, Jaipur and Sydney. If you see here, Jaipur is common, but Sydney is new here, it is not present. So we can apply some kind of set operation like union, intersection, difference, symmetric difference. The first union will add all the elements from this first set with the next set, and duplicate will keep only one time. Jaipur won't be duplicated 2 times. So end result will be 5 elements. So this from the top element, the Sydney will be added. And in case of intersection, only Jaipur is present in both the cases. So Jaipur will be returned. And differences, if you use this difference like this manner, like only this favorite cities record which is not available in cities will be returned. In this case, this favorite city is coming first. So Sydney is the additional element which is not present in the other set. So Sydney will be written here. But if you want to see this symmetric both the differences in irrespective of which one you are calling first or last, so it will show all the differences. So these 4 records or 4 string is not available in any of the HashSet. Now we'll talk about a slightly different topic than the collection. We'll talk about box type. Box type is a smart pointer. It is used to allocate memory in the heap and store pipe in the heap memory. If you don't use box, by default all primitive types such as integer, floating point numbers, characters stored in a stack. We have created a point struct with 2 attributes x and y. And derive macro is going to help printing the point instance into the console. So P is an instance of point and x and y both primitive data types. And the instance of P is also stored in a stack memory. Now let's wrap P with a box which in turn allocate the heap memory to store point instance. If you print, there won't be any difference between this P and box P. As I talk about star, which is a dereference operator earlier, using the star operator or dereference operator, we can extract the actual value pointed by box P into the smart pointer. So P2 is in turn a type of P point. So we can wrap box type inside another box type. It is correct syntax but have very less real usage value. But this is I am trying to demonstrate how the box memory utilization will work out. to explore the memory usage, various point of instance, like how the memory allocated by this P instance, box P and double box P, let's explore. So for that, let's use the memory module from the standard library. So we have imported a standard memory module which gives the basic function for dealing with the memory, like we can check the size and where it is allocated. So if you see, as I said, like point will be allocated in a stack memory. So both x and y are floating point numbers 64 bit. So which is translate to 16 bytes. So if you see this memory usage here, memory usage of P instance is like 16 bytes. Whereas box P is 8 bytes and box P is 8 bytes. It looks pretty strange that box is always returning like 8 bytes. Whereas the point instance is more, because this is stack allocated and it is written in memory size of values, written the size of pointed to value by the pass by reference in bytes. So it is how much memory is allocated in stack it will return. So how much the reference actually contain the data. So if you add additional Z as a floating point numbers, and then 16 bytes will be modified, will be changed, updated to +8, that is 24 bytes. But this box P and box P will be still 8 byte, because it only contains the information, the address to the heap allocated. The heap will grow, but that actually stack usage would be still 8 bytes for both box P. So in some use cases, like for example, nested data structure or not list, you may have to explore usage of box, because using this integer there is some limit. Heap inside like stack memories, but in heap you can grow to in larger quantity about memory usage. So most of these code examples are from Rust example book. Please check the link in the description below. Thanks for watching. Have a great day ahead. Bye bye.